This video accompanies Learning IoT with Python and Raspberry Pi. In this video, you will learn how to write while statements. The final scripts in this video lecture illustrate how to cause the piezo buzzer to beep continually using a while statement. Hence, you will also need a half breadboard, a piezo buzzer, and 2 female-to-male jumper wires. Suppose you want a block of code to execute repeatedly as long as a certain condition is true. That is, you want the block of code to loop. A while statement begins with a while keyword, followed by an expression that evaluates to true or false, followed by a colon. This while statement is composed of a single clause. Notice that the suite is indented 4 spaces with respect to the clause header. A while statement can also have an else clause, but we'll only discuss single clause while statements in this video lecture. We'll consider 3 types of while loops: an infinite loop, a counter control loop, and a sentinel control loop. This flowchart represents an infinite while loop. The while loop begins, the suite executes, and then control flows back to the beginning of the loop, and the suite executes again, and so on. The header of a while statement that executes as an infinite loop is just the while keyword followed by the bool value, true, followed by a colon. Let's consider an infinite loop, each iteration of which the user is prompted to enter a travel destination. After the while statement, we'll add a print function call. We'll save the script. And run it. We'll enter Miami and London. Infinite while loops can be exited by pressing Ctrl+C. Notice that traceback information is printed out to the shell, something which we prefer to avoid. A try except statement can be used to handle a keyboard interrupt gracefully. The while statement is placed entirely within the try suite of a try except statement. When the user presses Ctrl+C, the while loop terminates and the except keyboard interrupt clause is executed. Then the rest of the program would continue to execute as normal. We'll modify the short block of code by placing the while statement inside of the try suite of a try except statement that handles a keyboard interrupt. But we'll leave the print function call after the try except statement. We'll save the code and run it. Pressing Ctrl+C causes a while loop to be exited, and the keyboard interrupt is handled by the except clause. A while statement can be written so that its suite executes a specific number of times. Before the while statement, the counter is assigned some initial value. At the beginning of each iteration of the loop, the value of the counter is compared to some other value. Because this comparison is made when the while loop first begins, the counter must have some initial value. Each iteration of the loop, the counter must either be incremented or decremented. Failing to include a statement that increments or decrements the counter would make this while loop an infinite loop. We'll write a while statement that loops 5 times. Each iteration of the loop number will be printed out. We'll use the variable I as a counter and assign it a value of 0 initially. The comparison is I less than 5. If this expression returns true, then the while loop begins. Each iteration, the print function is called, and I is incremented by 1. We'll save the code. And run it. Another way of having the loop iterate 5 times would be to initialize the variable I to 5, use the comparison I greater than 0, and decrement I by 1. The third kind of while loop we consider is a sentinel control while loop. A sentinel control while loop ends when some value is equal to the sentinel value. The value being compared to the sentinel value might be read from a user, from a sensor, from the internet, etc. There must be an initial value with which the sentinel value is compared. Each iteration of the loop, a new value is read in. At the beginning of each iteration, the current value is compared with the sentinel value. Like the counter control while loop, and unlike the infinite while loop, the sentinel control while loop is designed to terminate without a user having to press Ctrl-C. Unlike the counter control while loop, however, the number of times the sentinel control while loop iterates is not known when it first starts executing. We'll write a sentinel control while loop in which a user is prompted to enter a travel destination. There must be a priming read for the travel destination before the while statement. The loop will terminate when the user enters exit. We'll save the code and run it. And we'll enter the two cities of Moscow and Helsinki before entering exit. We'll write a script that calls the beep method on a buzzer object from within an infinite while loop. The piezo buzzer should beep a random number of times each iteration of the while loop, and will also include exception handling. We plug the piezo buzzer into sockets J1 and J8 such that the positive lead is plugged into J1. We'll plug the male end of the red jumper wire into socket F1 and the female end onto GPIO 17, and the male end of the black jumper wire into socket F8, and the female end onto one of the ground pins. The sleep function must be imported from the time module, the randint function must be imported from the random module, and the buzzer class must be imported from the GPIO 0 package. In order for the buzzer to beep a random number of times continually, we use an infinite while loop that will be exited by the user pressing Ctrl-C. We'll create an instance of the buzzer class with 17 as the argument and assign it to the variable buzzer. The while suite consists of the randint function call assignment statement, the beep method call, and the sleep function call. We'll use a try except statement to handle the keyboard interrupt and a generic exception. Note that the entire while statement must be placed inside of the try suite of the try except statement. And we'll call the close method on the buzzer object from within the finally clause. We'll save the script We'll modify this script so that the while statement keeps iterating until nbeeps is equal to 4. We'll also add an assignment statement for nbeeps before the while statement, change the while header to while nbeeps not equal to 4, and move the nbeeps assignment statement to the bottom of the while suite. We'll also add a couple of print function calls, and we'll remove the keyboard interrupt clause. We'll save the script and run it. Disconnect the jumper wires when you're finished experimenting with the circuit. Go to www.learningiot.net for links to where you can buy Learning IoT with Python and Raspberry Pi.